In this experiment, so what is your voltage? It's an experiment that's designed to determine the voltages of various half-cell reactions, and we're going to prepare some half cells. I'm going to do 3 of them. Copper 2 nitrate half cell, copper metal sitting in the copper 2 nitrate solution, a piece of zinc sitting in zinc 2 nitrate, and a piece of lead sitting in lead 2 nitrate solution. The reason for nitrates, for one, we're reducing the number of variables, and secondly, all nitrates are very soluble and they're not easily oxidized or reduced, and therefore the nitrate ion will not affect the experiment in any way, shape, or form. The salt bridge could be one of 2, and I'm going to show you each of those. One of them is just a string soaked in a solution of potassium nitrate, and the second, I'm going to cut up a piece of filter paper and use that for my salt bridge, also soaked in a solution of potassium nitrate. Sodium nitrate would also work just as well. So that's what I'm going to be doing, and we're going to be using some micro well plates. The large well holes are going to be used for this, but you can also use the small well holes. I have my setup now, my LabQuest 2 hooked up to some connecting devices which registers voltage. And I've already put my salt bridge in, but we'll see what happens when I take it out. I'm going to connect one of the leads to the copper and the other one to the zinc, copper sitting in a copper 2 nitrate solution. Now, they make good connection. Try to get the voltage to read. Notice that the voltage close to 0.80, right now 0.829, 0.828. Okay. If I hook up this to the lead and this one still to the zinc, I'm going to get a different voltage. If I can get this connected. Cooperates. This red lead's having some problems, having some issues here. Notice there's no voltage at all. Well, there's a very good reason why, and that is there's no salt bridge connecting. So I'm going to take this salt bridge string out and change up with a different piece of string. So here now I'm going to connect the solution of the lead 2 nitrate with the solution of zinc 2 nitrate. Let's see what happens now. Now that I have a circuit that's completed, maybe I'll get a voltage. And look at that. 0.13 is what I was reading initially. Let's see if I can use my forceps here to make a better connection with the lead. 0.29 volts. If I have that reading, and then I take my salt bridge out, look what happens. The voltage drops to 0, or essentially 0. put it back in. It's very close to that. Okay, and then my last connection, I'm going to change the salt bridge. And this time I'm going to put it between the copper and the lead and see what happens there. Copper. And again, I'm going to use a little bit of help holding that piece of lead in place. Negative 0.46 volts. Why the negative value? Well, the sign of the voltage just tells us something about the direction in which electrons are moving through this LabQuest 2 and through the wires. So we then need to figure out for the other metals the potentials. Now the second way of making a salt bridge is using a piece of chromatography paper, filter paper if you will. And all we're going to do is cut up a piece. We can just connect two, or we can make a connection that will connect multiples. So I'm going to soak my salt bridge in solution of potassium nitrate, and now I'm going to connect these two. I'm going to take out my salt bridge for the copper and the lead and put my salt bridge into those two solutions so that I have a completed circuit. Let's see what happens now with this. Connect the copper. And then we're going to connect the lead. And you notice we read 0.50, but negative 0.50, just about what we read before with the string as the salt bridge. So we can do all of those two different types of salt bridges.